Well, hi, and welcome to my shop, and thanks so much for joining me here today. It's June 11th, a rainy day, and I'm going to be in my shop a lot today getting a fair bit of work done on this radio. There's a few more things to do with it, so let's just take a little bit of a closer look. So a couple things to do with this radio. Really circulates or circles around the capacitors. I have mixed feelings about doing the capacitors in this radio. Now normally I would just get in there and kind of change all these older ones, but the radio's working really quite well, and there's a risk in anything you do, and it would be a really sad thing if I worked away on this and in the end there was more trouble in it, and that's quite possible. So I'm hesitant, but at the same time I feel a little bit compelled to do something about some of these capacitors. So one is this one. So this is a Hunt's molded capacitor, and it's right across the power line, I'm pretty sure. Yeah, I can see it right across the power line. This is the plug to plug in the turntable. So there's 120 volts. Niagara Falls is pushing on this little capacitor here. So I'm going to change this one because of the hazard it represents. I don't really know how serious the hazard is, and the hazard is this thing can explode and maybe set a fire off inside the radio and burn down your house. But I think the chances of that are really extremely remote. Extremely remote. But no harm in changing this out. It's probably playing some other roles. One of them is quelling any radio interference that's coming in on the power line. That's probably maybe the main reason it's there. So I'm going to replace this one. I have some special capacitors. I'm happy to put one in here. Now looking at the rest of the radio, there's a few different kinds of capacitors in here. I already kind of looked over these power supply capacitors, and the radio's not humming to any great degree, although I've been playing it on these relatively small speakers, and in the cabinet, as I'll show you in a little while, are some really decent speakers. Probably replacements, in fact. I got a note from one of you saying, hey, those speakers in that cabinet, when I showed them briefly at the start of this video series, look like replaced speakers. So we really need to find out if there's a hum coming out of this thing by having it play through those big speakers. So maybe these have to be changed, but for now I'm not going to do it. It's expensive. Ultimately, this console is going to go for sale in a store in Toronto. It will be sold for not much money. So really, the sellers cannot afford to pay me lots of money to change a whole bunch of parts to make something work that's already working. I'd rather sell it for a lower cost, have it move out of their store, and the next person who owns it hopefully can deal with any longer term restoration issues that they might be interested in. My job is to make sure this thing works and is reasonably reliable in its condition, so they can sell it and know it's not going to fail in 3 weeks or something silly like that. I think that's the condition it's in right now. In fact, I think it's in saleable condition. So, okay, how do I approach this? So I'm committed to doing this guy. I have these yellow ones here, which I've kind of convinced myself have been installed as a repair. I'm sort of semi-convinced on that. Anyway, these are highly reliable type capacitors. It has a lot of these wax ones that look really great. These look really great. How they look and how they are doesn't necessarily jive, but these look like extra expensive capacitors. They don't seem to have a wax on the outside of them. They seem to have a plastic shrink coating which seems to be sealed up very carefully at the ends here. So I don't know, this might be some attempt to make a better paper capacitor. I don't know. These ones, these are also probably paper inside, paper and oil, paper and wax, and they have a type of plastic molded over them, again to try to improve the hermetic seal. These have been known to turn out to be poor, to some degree due to internal problems, perhaps contamination rate in the manufacture. It's very hard to manufacture totally uncontaminated with ionic materials inside the paper or the oil that's inside here. So what to do? So I think I'm going to take one of these out and test it and start making judgments about the condition of the rest based on the one or two. So I'm going to pick some critical ones that, you know, changing them unnecessarily, or how can I put it? If they're slightly weak, changing them is still helpful. That's what I kind of want to pick off. We got a couple here that aren't that important. Got some tone ones over here. The tone control seems to work. I don't think they're too critical. Got a couple here that are going to these two tubes. So it's, let's see, they're going back to a common spot, which looks like a grounding point. Very much looks like a B minus point here. I'm not sure. Well, red wires. So these it's confusing. This red wire is a big B plus wire, but these ones are coming from the output transformers here. So I don't know, maybe these are outputs. In any case, they're associated with the two output tubes. I'm a little concerned about that. And another thing to be concerned about was, didn't I check this? Wasn't there a single, oh, it's been so long since I've been in here. I think there was a single resistor shared, cathode resistor shared, and a cathode bypass shared. So the grids of the output tubes appear to be protected by these two capacitors. I'm not too worried about that situation. So let me change this guy out. Then I'm going to look at the schematic, figure out which one of these I want to go at. It's going to be one of these two, I'm pretty sure. And we'll go from there. You know what? This might be conveying. Don't even talk about it. Let's do this. So I'm going to snip them out. Hunt's AC 117. So this looks like this is an attempt to make a ruggedized capacitor that you can put across the line and not be panicky about should it fail. And it looks to be in really good condition. There's no cracks. 0.1 plus or minus 20%, 600 volt DC working voltage. Let's put it on the tester and see what happens. So this is my capacitor tester here. You know, my shop is full of vintage equipment to do the vintage work. I kind of like the whole deal, but often when I'm using vintage equipment, I have to pay attention to little quirky things about it. The quirky thing about this, it's not really quirky. It has nothing to do with it being vintage. It's not really quirky at all, but when it says 25 volts here, it's really 50. Not that that's going to matter. So we watch the magic eye here to see how it operates, what happens on the magic eye. When I hit this switch, I'm going to put 50 volts across this capacitor. Some amount of current is going to leak through the capacitor. If the capacitor is new, the leak will be so small as to be unimportant or even considered zero. What will happen here is the eye will pop close for a minute as current flows in to charge the capacitor, and then as that current fills up the capacitor and slows down, the eye will open. A good capacitor is going to open up just like you see it now. A bad one, I think we're going to see what a bad one looks like. 50 volts, can you do it? And it opened right up. So definitely in the realm of a good one. Okay, I put 150 volts on it. Now it's barely opening. I put 250 volts on it. No hope of it opening. So this isn't telling me the capacitor is ready to explode or anything like that, but it's telling me a small amount of leakage current will flow in it. With this position basically across the generators at Niagara Falls, that tiny little leak won't matter. is approximately a half of a drop of water going over the falls is being wasted inside here. Not even that much, because it's, you know, the falls are pretty high. That's quite a big drop at Niagara Falls. So the static head, or the pressure of the water in the water supply pipe going to the generators, is gigantic. So I don't think we're going to cause a dimming of the lights anywhere in Ontario because we have this, but I've cut it out. There's nothing wrong with it. I shouldn't say that. I've cut it out. There's nothing wrong with it for its purpose. But it's out now. It's not going back in. I will install a new one there. I'm going to replace it with this guy here. This is an X-type capacitor, sometimes called a safety capacitor. And my understanding of it is these just cannot, under any circumstances, cause a fire. That's my basic understanding of this guy. And we easily put them in here. Put the label side up. And away we go. Nice and tight. Okay. My wife and I, we were in Ottawa for the last couple of days. Ottawa is about a 5-hour drive from here, right across central Ontario. And on the way, of course, we're driving through some small towns. We stay off the big major highway because it's not so pleasant to drive on these fantastic, can't call them back roads, but lesser highways through Ontario. Just fantastic. And we stopped in a small town called Haliburton. Haliburton's the mineral capital of the world, rock hunting capital of the world, or something like that. We can go to a long discussion of the geology around there. It's quite interesting, but I won't. We stopped there to get a sandwich. We're going to stop at a Subway shop and get a sandwich. Now, so that's a small town. I'm from a much bigger town. We got 30,000 people here. I think there's like 6,000 or 5,000 in Haliburton. My wife and I are thinking, oh my God, we're going to put on face masks and go into this little Subway shop, and we're going to look like we're from another planet or something. But we're committed to this. So we put on our masks and went in, and what did we see inside? All the employees had masks on, and all the patrons had masks on, including children. And nobody's sick. There's nobody sick. There's hardly anybody sick in Ontario anymore. Yet there we are wearing masks. So if you're Canadian, we have done the right thing. Let us continue to do the right thing for our own sakes. We are in a winning position here, and if we do the right thing, we will stay in a winning position. And so I'm so excited about that. I can't begin to tell you. When I got to Ottawa, everybody wearing masks. And there's no cases in Ottawa. Ottawa is a city of 1 million people. No cases. Everybody wearing masks. Thumbs up to Canada. Whoa, I'm so happy to be Canadian. Okay, enough of that. I'm really trying to stay away from that topic, but clearly unable to. I just wanted to say something to my fellow Canadians, because I know Canadians watch my videos. That's good. Now, we gotta pick another one to. Let me change the camera position here. Okay, so I've got the pin out for 25 EH5 up on the screen, so we can figure out what's going on with these pins. when I look at these, I don't have a schematic. This would be easy with a schematic. But without one, not so easy. The easy part is making mistakes. So I'm seeing two capacitors coming from pins going to a common point. That terminal is got a wire going to this terminal. They're the same terminal. I'm seeing red wires. These red wires are going to the two output transformers for the two speakers. And over here at the other end of this capacitor is a blue wire. Same thing under here, you can't see it. The blue wire is the other wire going to the output transformers. So I'm thinking this is a grounded point, although I have been unable to prove it, that it goes to B minus exactly. So pretty sure these are on the output. Now let's look at the diagram there and see what it says. What's it say? So the plate is on pin 7. So let's look at this one. Look for pin 7. Okay, so what they have on this socket comes with 1, 2, 3, 4, 5, 6, 7, 8 pins, but there's only 7 in the tube. So one of these terminals is a fake. So I'm looking deeper in to see the actual prongs coming up from the tube, and I can see there's no prong in this one. So this is just a connection terminal. And that's also, that makes this pin 1. And that makes this pin 7. Pin 7 has got the blue wire on it. Pin 7 is the plate with a blue wire going to the output transformer. That makes perfect sense. And also on the output plate pin is this capacitor. Again, this is almost certainly a grounded point. I could prove it, but I'm not going to bother. So in terms of important capacitors, I think these guys would be, because I'm guessing they've got B plus across them. Interesting enough, B plus for this tube. Look at this. It's down here somewhere. Somewhere there. Plate voltage, 135 volts. So I'm thinking that's a pretty curious number there too. 117 volts. Kind of matches the your outlet voltage, but that's a coincidence, I'm sure. This is a DC thing anyway. But 135 volts. It's clear that this tube is built to be in radios without a power transformer. Very good. Take one out. Very convincing. Now what would happen if one of these was leaky? Probably not an awful lot, because it's a low impedance circuit, and a little extra current leaking through a capacitor probably not going to cause much trouble, if any. So the objective here is to find out the condition of these particular style of capacitor in this radio based on a sample. I have the sample. Let's go over here. See what we can do with it. Here we are. I think you can see the gap in the eye. Make sure that's on the lowest setting. 50 volts DC. Okay, what is the guess? My guess is it's going to come out the very same as the last one. It's going to look okay at 50 volts and bad at any higher voltage. Here we go. Ooh, popped right open. That looked really good. Here we go, 150. Popped right open. 250. Right open. Okay, so at this point I started wondering, have I connected this properly? Maybe the clip lead didn't take. But what I notice is when it opens, there is a slight delay to it. Just from my experience, I can see it. So I know this guy's charging up. So considering it's got no leak at 250 volts, no measurable leak, it's worthwhile to check this guy for his rank, his rating. Let me just read what's on it here. This is a pyramid type 3, 0.0047, so 0.005 is the supposed capacitance. 0.005. Okay, I'll go over here. 0.00 5 will be on this scale. Now the idea is for me to swing this knob around and watch for the eye to pop open. There it is. That's a very distinct spot. It's not happening down at the ends of the scale where this machine is not reliable. It's right in the scale. Right up, a slightly leaky capacitor under this test won't open the eye all the way. So it's another suggestion that this capacitor is on the money. Now we look carefully at the scale. I don't know if you're going to be able to see it in the camera or not. You'll have to trust me on this. If I just 0.005. In fact, it's ever so slightly less. It's even closer to 0.0047. So this capacitor is perfectly good and perfectly serviceable. So I think what I'm going to do is I'm going to put it back in, as crazy as that might sound, because that will keep this receiver in virtual like new condition. You know, one of the side things you want to try to do with these old guys is keep them as original as possible, I think. Some might disagree, but in a case like this where you've got one, it's made it to your shop and it's in this kind of condition, unless you own it, you can do whatever you want if you own it, but if you don't own it, it might be a little questionable about and having said that, you know, putting this back in is going to be a little tricky because I've cut the leads, of course. I'm debating what I just said now. Should I really tack them back in there? And it's not actually long enough, of course. How can it be long enough? Well, I'm going to put one new, nice looking new one in there, I guess. What I'll do, 0.05, 0.005. Lots and lots and lots of those capacitors, so. But I think based on that test, I'm not going to do anything else. The receiver works well. There's no obvious problems with it. There's I need a little bit of tubing here. Yeah, driving to Ottawa, that's not enough. Driving to Ottawa from here takes us, my wife and I, through countryside, if I can call it that. Heavily glaciated land. Of course, all of Canada is exactly that. And I've been studying the geology around glaciation. My eyes are open as I drive along looking at stuff. For instance, when you're driving into Ottawa from this area, you're very likely to drive through a town called Renfrew and then get on a highway that's like a much bigger highway and head right into the city from there. As you're driving down this much bigger highway, you suddenly see rock along the highway that looks unusual from anything else you've seen. Man, I've driven all over Ontario, and up comes this. Oh my God, I can't think of the name of it now. Rock that forms at the bottom of a body of water. How can I not? Sedimentary rock. Holy smokes! And there it is along the highway. As you're driving along, looking at it, I wonder where that came from. It's very odd. It's very, very flat and level. It's not wavy or disrupted like most of the rock around here. It's totally disrupted because of things that have happened. Well, it turns out that rock's not that old. You know, in the scheme of things, that rock was formed at a time the Atlantic Ocean reached all the way in to Ottawa and beyond. Yes, ocean water. How did the water get in there? A big heavy glacier pushing the ground down to the point where the ocean flowed in through the St. Lawrence system. And ocean water came right in and stayed there maybe 1,000 years or so. And during that time laid down these rocks, which are very close to the surface, which is why when they built the road they exposed a lot of it, because it's just under the surface. Now other sedimentary rock laid down, a million years ago, that rock has always been disrupted. It's always going tipping up and down, and pieces are missing, and it's kind of messy. This stuff's not. It really stands out. And if you've ever taken this drive, you've seen this rock and probably wondered, well, if you're like me, you probably wondered, how did that get to be like that? Well, that's what it is. It was called the, I'm going to forget the name of it, the sea. The Champlain Sea. And it would be there probably 5,000-6,000 years ago for about 1,000 years. Something like that. And it would just be laying down this sedimentary rock just based on dust and dirt falling into the water, sinking to the bottom. There was nothing alive at that time, pretty sure. Oh no, what am I saying? That's not true. Lots of things were alive. People were alive. That's the thing about Canada and other northern European places. Glaciation is what you see everywhere you go. No matter what it is you're looking at, glaciers caused it. Glaciers are vast amounts of water associated with the glaciers receding. Vast oceans, an ocean worth of water once flowed basically over my house and everywhere around here. Of course, nobody knows the exact situation that occurred, but it must have been just unbelievable. I'm talking a lot and doing a small amount of work. Well, that would be it. That would be it right here. That would be it for me. Thought this one was worth doing, this one not worth doing, no more worth doing. The next thing is to get this guy back into the cabinet. Let's just take a peek at the cabinet, and I'll just do this on my own because it's too much grunt work getting something like this back in. But just to remind you what's in there, there we go. Good show for me. Well, we're going to look at those speakers, weren't we? Let's do that next. Okay, so you should be able to see the camera down there, and we'll just look at what that camera is seeing. Two speakers. Now look at the one on the right. I can see the word realistic on it. I'm pretty sure that's a Radio Shack speaker. So yes, I think these have been replaced. I can't imagine them too. Yep, realistic. Huh. Well, that's actually really good news for this thing. We'd have to guess those speakers are just fine and are good quality. Great. Okay, so I'm going to continue with the installation. Those speakers can stay just as they are, and when I get it all done, we'll have a listen, be able to play a record and see what we got here. But I think it's actually pretty good. Okay, so I got another idea here, and it's not really to show you my old slippers. It's really to test the hum level in this receiver before I kill myself reinstalling it and then find out that it does in fact hum with the bigger speakers. So I've wired it up in there, and I should be able to turn it on. I have another microphone I don't use very much, which I'm going to use, which is much closer to the speakers. I'm just going to switch to it, and got my own headphones on here so I can hear what's happening. Here we go. Different microphone now. Okay, so this microphone is really close to the speakers. If there's a hum, this guy will reproduce it too. Here we go. Oh, power. There it goes. Okay, it's already on. Did that with the dim bulbs. Let's have weird volume controls down. Yes, everything's down. Turn it up a little bit. And what are we on band-wise? Turn it down. Find the band switch, Tim. This is also the on-off switch. Let's go all the way this way. It's phono, AM. Okay, AM. Should you hear AM? Here we are. Now what we're trying to spot is a hum, a low hum. So I don't know. Ooh, I certainly hear a hum. Now you hear it. I hear it in my headphones. Let me just take those off. So with the headphones off, the hum is not actually noticeable. Let me just move around here because sound is a funny thing. It does funny things. I'm going to get right in front of it. So the hum is coming out of one speaker. It's very, very low. That's probably because that's the AM speaker. It's coming out of this one here. Let me turn it up. That's the speaker that's operating there. So we'll switch to FM now. If I can just do this correctly. Let's go phono, AM, FM. Ooh, that sounds like AM. Oh, that's AM and FM together. That's FM. How do these volume controls work again? I'm hearing it coming above. So as for the hum, yikes! Hey, what's happened?
Young people who wanted to earn money through the chaos students.
Turn up one side. Oh, you know what? We're not on full voltage here. Let me turn the full power on. Okay. So now it's getting its full 120 volts. I'm operating this radio with no FM antenna at all. So whatever I reasoned out about how this volume control works, it wasn't completely right. You're still able to get FM to come out of both speakers. I guess AM too. Some more complicated switching in there I never really picked up on, but that doesn't matter. As for the hum, there's really nothing here to even think about. Thumbs up. Thumbs up on that. Great. Okay, so I'll put it back in the cabinet the proper way. We'll see what happens when a record gets played. Okay, I think I got everything screwed in there together. I'm showing you this to show you what I did. I tipped the whole console on its side to make this easier, and boy, did it make it a lot easier. It's still tough, very tough putting those screws in, but having this on its side saved me from having to support the radio while I was trying to install it with all those screws, which I'm sure would have been a disaster. So, okay, we're just about ready to actually test this guy out. Okay, I've reached the knob on stage now. These really don't look keyed. I think I noticed that before. So, we'll turn this all the way. Put this on as 88. this one away. Right. Oh, that's the one there. Okay, what's happening here? That's the end. And we're at the end. Put that in pointing just below there, I think. There we go. Put the knob on. You probably can't hear me muttering here. I haven't got a microphone on close to me. There we go. Not bad. Whoa, this one went a little too far. I should really do this with the set operating, but I'm taking a guess here. Let's guess that. Hope having it symmetrical is going to do it. Well, maybe when we turn the FM on, we can sort this out more and more. Exactly. Now the rest of the knobs. This is the double knob, which is keyed. Isn't there a special one to go in there? A little bit smaller. Oh my gosh, maybe not. Okay. The on-off band switch here. Well, it's currently switched off. There it is, all knobbed up. All knobbed up with some place to go. The next thing to do is to plug it in and see if that record player still works. And play a record. Great. Okay, well I think I've got everything back to the way it should be. So we're going to give this guy a go. Switch him on. Let him warm up. See what we get. So, record player's going. Volume up. So this is FM first, with the internal FM antenna connected. What do we get?
Demonstration was, but he wasn't remarked by mall security. So good. I mean, he was safe. He definitely had his face covered, but you know, not in a good way. So just wear a mask. Just wear a mask and leave the saran wrap at home.
Saran wrap. That's a very weak station.
Because I think you just saw. Well, that's the surprise. Our short-term memory is much shorter than most people realise. The surprise is when you look very carefully at occasions where people have forgotten one of the vehicles, what predicts whether they forget it or not isn't how long they've looked at the motorcycle, it's what they do next. So the longer they spend looking at other things, the more head movements they make after looking at the motorcyclist, the more likely they are to forget it. So we interpret that as some kind of capacity limitation. Other things you've looked at later on have overwritten your memory for the motorcyclist.
You're saying there's actually a temporary memory loss, that there's sort of a little tiny
Well, I'd like to listen to that. That's a science show on the CBC. That's on a few times a week. Quirks and Quarks. You can get all the CBC shows on the internet at the CBC website. So Quirks and Quarks. If you like science shows, that's a great one. Let's hear a little bit of music though.
I can't believe summer is finally here. There's so many things I want to do. Like getting a cool, creamy Wendy's Frosty made with real Canadian dairy for only 99 cents. The next thing I'm going to do is, you know... I'm generally a pretty confident guy.
And 20 years on the radio in cities you can't pronounce.
My dude, what are you doing with your life?
It's Scott Jackson and the Life Retro Show.
Well, that's great. Okay, so that first setting, that's FM, FM, AFC, FM, AM. Let's go all the way to AM here. So they're now on the AM radio. Yeah, that's pretty typical. Let's see what we get.
High intensity, high tempo playoff game. First you have the play-in round, and then there's teams that have the bye. There's no one in the building. I watched MLS again last night. I don't know if you've watched any of the MLS games, but it's so...
At 520,000
Well, that's actually a pretty good showing in my basement here for an AM radio with the antenna not particularly aimed. So the antenna could be aimed wrong, but the fact that it's picking up some stations is a big thumbs up. Okay, let's try a record. Now, what I've done is I've tried to find records that I think won't have copyright problems on YouTube. I have the feeling there's almost nothing. Well, look at this one. Great musical masterpieces. 5 record set of the world's most beautiful music. $10 bucks. $10. So let's see what we got here. We'll just pick one. Great Broadway shows. Oklahoma. You know, that's a very common. That's not. Let's find something just a little more obscure here. Let's try this one. We'll just try this. So what happens on YouTube if I put copyrighted music on for any more than about 10 to 15 seconds, YouTube will pick it up. The owner of the music, the holder of the copyrights, then invited to take over any revenue that my video or a video might earn. And you don't get in trouble at all. It's just you don't make any money. Not like I make any money anyway from these things. But I try my best not to crash into it. Look, there's 13 songs on this record. Merry Widow Waltz. Light Cavalry Overture. Okay, lots of different stuff. Let's just let her rip. Phono. 33 on the speed. Oh baby, here we go. Oh, it's still doing that hop. Oops, a little bit of adjustment is needed. Got the volume up fairly high. There's a strong hum, but you can't hear it over the program material. So the hum, oh, the hum is my hand. Touching any of the metal parts here. So the power to this turntable is plugged in with a 2-prong power plug, very much like an ordinary wall outlet. It's not polarized and go in this way or that way. I'm going to reverse it. Go around behind here to do it. I think it's right here. Didn't make much difference. It didn't make any difference. Now, is that hum really just from the record player? I'm going to switch this. Well, you know what? So the hum is related to the volume control. There's a chance there's a ground wire that runs from the record player onto the stereo chassis, and I haven't connected it. That's probably what this hum is from. So the whole platter here is a piece of metal floating in space. So it picks up signals, including 60 cycle hums and things like that. I have a lot of 60 cycle hum in me. We all do. And if I present myself close to it, oh, we can't hear it now. I'm just adding my hum to its own hum. I'm improving this as a hum antenna. So I'm pretty sure I can eliminate that. Hey, let's let this cycle through here properly. Oh, right on the end. Now you see it's not moving forward. That's for a couple of reasons. One is the tone arm is too light, and literally as the tone arm is being pulled forward, it's not going, it's too light. Instead it's just skipping back on the groove. The other problem would be that the velocity sensor it's just got too much back pressure on the tone arm, and it can't push the velocity sensor forward. Again, that's because the cartridge or the needle is not hard enough in the groove. So I'm going to help it out a little bit here just for the sake of this. That's not going to work. Now let's try to help it out another way. Need a little bit of weight. Okay, we're going to use a pair of walruses here to weigh this down a bit. There it goes. Walruses and all. Okie dokie. So it's essentially working. Not too bad. Not really too bad, considering lots of stuff. So I think that's going to be it for this guy. I'm just going to heady this up by moving the spring load back here. You can also add weight. This may have been designed for a heavy cartridge. Now it has a little, very light plastic cartridge in it. It's probably expecting more weight way out on the end here. If you notice, when I put the walruses on, okay, I didn't try to balance them out here. I put them way back here. Because, after all, it's a lever, right, with the pivot at the very end. What's that called? A class 1 lever or something like that? So you could do the same thing. You can take some kind of weight, you can place it anywhere in the tone arm underneath where it's not interfering with anything, and add a little bit more mass to compensate for the lack of it up here in the head, which may be a better move than trying to adjust the spring at the back. Anyway, I think that's it. I think that's it for this guy. Pretty happy with the result. And there we go. Thanks a lot for watching this series. And I will very soon have another radio, a real interesting one in here. Next. Have a great day and see you again.